there are 121 lines. Okay, I'm gonna go through line by line on this code GPS DMS.py. Okay, and we're gonna remove that. Okay, so now I'm gonna go line by line of GPS DMS.py. The DMS stands for degrees, minutes, seconds, and this will be using a Raspberry Pi Pico and the GPS module, the Neo 6M. Okay, so now line obviously first is going to be the pin, the UART asynchronous transceiver receiver protocol, and then I2C protocol and U-time. Now, from my understanding, I don't think I need I2C. I think I just left that because then it would be like, why am I using I2C and then UART, of course. So then I have U-time. You also can use other stuff, but for now, U-time is really good because we're going to get into that. It uses something called ticks. So the first thing is GPS module is just going to be an object for the UART. So I want to assign it as channel 1, the baud rate, or how fast do I want the frames per second, 9,600 frames every second. Transceiver pin 4, receiver pin 5. This is all on channel 1. Now, if we went to a different channel, you'll use 8 and 9. I think that's like 0 or something like that. So then we got, these are flags. They're just called timeout and fixed status, but you could call them whatever you want. These are flags that will eventually become true or false, which is false, obviously a 0, true, obviously being a 1. Then you have latitude, longitude, satellite, GPS. These modules are not used, but they were from the original code that I got from the internet, so I just left them there. Well, actually, no, they are used, but I think these two are not used. I'm pretty sure. So, I mean, it's not like it would matter, but, you know, it doesn't matter. All right, so then threshold. This threshold thing should not be used, as it's quite meaningless. That was some code I was trying to do. This, I'm pretty sure I'm using the current latitude, previous latitude, current long, previous long. These are for modifying the code because I want to find the difference in the change in time. So, you know, this is standard practice using current and previous. Max, I used some code. I created my own code now from this. Basically, I wanted to get the max of the latitude and longitude and the min. Basically, I want to get a range. What is the standard range of these values from the greatest to the least? That's what I want to know. Now we get to the definitions. This is get GPS, and we have a parameter as passed called GPS module. So the first thing is you have to make these global in Python. I had learned that, so I don't need this, I don't need that. But I had learned that, and I was like, what? In C++, you don't have to really do all that. You just make it global, and that's it. You know, but yeah, that's it. So that was the only thing that was odd, but either way, let's keep going. So we get the timeout, and timeout uses ticks. You have to add ticks. So like basically, from my understanding, is that this is not really a timer. It's really getting the amount of ticks or shifts in data, I think. And so they call it ticks in milliseconds. So I think what it's doing is it's just as the program begins, it's going to iterate, I guess, shift a number of bits. And when it's shifting, it's like, all right, well, it's tracking that. And then you're saying, okay, if you shift X amount, say 30,000 times, we will mark that as I believe it's supposed to be 3 seconds. So it's going to keep adding that to U-time ticks add. And so it's going to add 30. In other words, it's going to say, okay, you've gone 30, you've gone 30, you've gone 30. So then it's going to send that to timeout. Timeout is just a variable that it holds. So let's read the comment. It says adds 4,000 milliseconds, which obviously I changed it to 3,000 or 30,000. So that's 30 seconds actually. So now we read it. It says 30 seconds to the current time, setting a point in the future when the timeout should occur. So we want to know when this occurs. Okay, if this thing lasts 30 seconds, then do this action. So every 30 seconds, do something. That's what this code says right here. Okay, so 2 modules you need is this one right here, and then you need to have your parameter, and then this will be added to that, and then you'll save timeout. So timeout will reference 30 seconds. So now let's go to this one. This one says run forever, right? So you want to take this ticks different. Now take the difference of the time you just added, which is 30 seconds, from the current time. If the difference between the time I just added and the current time is less than 0, then timeout. In other words, there was no change in time. That means, hey, something bad happened, right? But if there was a change in time, then something that this will never open up, right? So let's go on down. Okay, we says any. This says it wants to get any data. So this is a part of I believe this is a part of like the UART. So this is like, yeah, this is part of UART because you're using GPS module. If we go out to the top, GPS module. So in the UART, there's in MicroPython, there's like different little things you can pass. One of those would be any. Any is basically saying get all the data. If there's any data, get it. It doesn't matter what it is, just get it. Then this one says bytes binary code being received from module. So now it's going to take this. That says if there's any data, open this up. That's all it's saying. Just checking and saying there's data. We see some, basically, if there's voltage changes, this thing's just going to be running all day because there's voltage changes. So then it's going to be like GPS module.read line. So you're going to read that line that you get. You're going to save it into this thing called buffer. It could be any name. It just happened to be called buffer. Now it says try is used to test code for errors. So now this almost reminds me of the do while, right? Do this stuff while you are not the exception, right? That's what it looks like to me. So basically try decode the binary data from the buffer, which is the data we received from human language, into human language. So right now it's just like nonsense, and then we're trying to decode it. Built-in method used for converting bytes objects into strings. So you want to take the binary data and turn it into human language. So that's what this is doing. So this is a standard here. UTF-8 is standard. I'm assuming 8 bits, and it's going to strip. Strip is going to be slicing this into bits. Then it's going to decode that. When it decodes that, which is what is it stripping and decoding? The buffer. What buffer? The one we just read, GPS dot read line. And then it's going to go into the buffer. Okay. Then it says accept. So it says failsafe use this object called string. So strip removes characters, any leading or trailing white space. So if there's spaces, it's going to remove it, or anything else like that, it's going to remove it. That's in the front or the back. Okay. So now string. This is going to take this, what we just did right here. So everything we just stripped of it and turn it into human language, it's going to take it, and it's going to turn it into strings. So right now this is right now just bytes. Then it turns it into strings if it says accept. So if there's a fail, it's just going to turn into strings. I assume it's not going to be usable because it's just a string. So it's like, if this is the first one that you want to do, which seems like it's the simplest, but if it's not, then it's going to go into here. If this happens, my code I don't think is set up to take on this because my code is not taking in string. But we will see. I'm pretty sure it's not taking in string, but let's see. It says buffer dot starts with. So this is just saying, does this start with this? Okay, then yes, if it does, which we're assuming since we're using the NEMA 0183 standard language. So then it says parts will be assigned. It says buff. So every time you get a comma, this will give you whatever data that is and save it into a part. So it says strip line into components based on the comma. Binary begins with 0, and there are 15 lines. Okay, so there's 15 lines, it means you get 15 parts. So you're going to strip it. Okay, so then it says, and that's, you can go on the internet and find out, okay, well, what is a part of each strip? It'll tell you. So we're only focused on parts 2 and 4. Okay, so this one says if the parts is greater than or equal to 15, meaning we have the whole entire line, and all parts are 1 through 8, not including the 0, right? Because we don't need that. 1 through 8. So I want to get all this data saying prove this. It says print this. I don't want to see that because I already know the code, so we're going to keep going. Then we go latitude equals DMS parts 2 latitude. Okay, so this right here, we're going to get into the DMS part. For now, just know that parts 2 is the latitude part of that whole entire line. Longitude is the part 4, and we're calling this null. So I'm calling it null because in previous code, I could have called it longitude or long, but I think I called it null because I was using if-else statements. But now, as you see, I'm not using if-else statements, so I can just leave it as null if I want or not, because it doesn't matter, because my other code is like, okay, if you are latitude, do this action. But if you're not latitude, then obviously I call it null because I'm just not using it. So this is the only one I'm really caring about. So this one says fixed status true. That will be used later. It's just a flag. Break. Okay, now I'm done. It's going to say wait 100 milliseconds. So then that's like 0.1 seconds. Wait that long. So now we get to where we started, which is in latitude, right? So this is a string, latitude. But this here is just a function that has these parameters passed into it, right? As you can see, data, word. So this is my data, part 2 is data, and then I have my word, which is lat, okay? So now, works both for latitude, longitude. So raw data equals float data over 100. Raw data is isolated. So this was just, if you go on the internet, you can find like how to convert DMS from whatever the other one, I think is decimal. So I want DMS because it seemed like it was a little easier to work with for me, given the fact, as we'll see later, what I wanted to use it for. So I'm using DMS. You could use decimals if you want. The code he used referenced decimals. I did not want to use that. So anyway, we have the raw data, right? Raw data is going to come in through data as a float, right? So that could be either latitude or longitude. Then you have degrees. So degrees, this is just going to convert it. So decimal will become integer of first part of the number, right? So degrees is just the first part of the number, and it will be an integer. Now, we're going to go to difference. This is a middle point to get something that I need to use twice, right? So difference says raw data minus degree. So I have the raw data minus degree, right? That means clearly I want a decimal, right? So it says difference between float and the integer part is a decimal. Then it says minute. Int float difference times 60, right? Clearly we're talking about 1 minute. So it says still float only need integer part. We'll use integer part in seconds, right? So if we look here, it's talking about taking the difference. So that decimal is a float. We're going to multiply that float decimal, which is obviously a decimal, by 60. Okay, so now we get 60 times whatever that little decimal is, and then we're going to turn it into an integer. So now we're not going to get a decimal. So whatever that number is, it's going to be like a one number, no decimals in between. If it's 2.6, it's 3. If it's 2.5 or 2.4 or whatever, then it's going to be 2. And depending on the math or whatever, how it goes, it could change. But for me, I know that it'll just be 3 or 2, right, for that example. So then we go down to here for seconds. This is the most important part for me because this is what I was interested in, was the seconds. So it took the float difference times, or it actually took the difference times 60 minus minute. So whatever that minute was is always going to be subtracted. So this should always work this way. Then we're going to take that entire thing, turn it into a decimal, and then we're going to multiply by 60. So clearly seconds is the only one that's a decimal, and that's why I want it, because it shows to me it shows the accuracy, right? It's like, okay, this is where we're at, what we're doing, how we're going to go about this, right? So now that I got that part, this is all still in the DMS, which is decimal or degrees, minutes, seconds. So if word equals lat, right? Because that's what I want to know. Then get the max. So we're going to get the max. Now this is all exited out, obviously, so we're not going to talk about that. Then it says else, get the max min again for the longitude, right? So it's like only for latitude, do this. If your longitude, do this. Once again, this was just a print message, and it just showed you what your degrees, minutes, and seconds was, right? That's all it was. So now we're going to get back to this. You want to find the range of something, right? Like, what is the range of these sensors, right? So you can do that. So here it's going to say get max sec parameter, right? That's why I just say para. So now we have the global. You have to have a global, otherwise you're going to run into errors. Diff lat, diff long. So these are just local variables that I needed. So now we're going to say parameter. Once again, lat. So parameter is going to be word. I don't think you can use it twice. That's why I just use parameter. So here you go, latitude. So if second is less than minute lat, so min lat, then min lat equals sec, right? So we're assigning this if this is the lowest one. So I'm going to keep going over and over. I'm low, I'm low, I'm low. So I'm going to keep updating it. If it's greater than that, it's going to keep updating that for max. So we got the min, max of those. Then it's going to take the difference. What is the difference between the min and the max? That, to me, tells me the range, right? Okay, we got this high value, that low value. What is the range, right? That's what I'm looking for. What's the range? Now, we do the same thing for longitude, as you see. Now, we print. Max latitude is the max, min is the min, end. So I use this to keep this on the same line and space it out. Then I say tab it over and tell me the longitude, longitude max, min long, and then end. Now we go to the new line. Actually, no, we keep it on the same line. It looks like. I'm gonna say keep it on the same line. Then it says tab it over again, difference latitude, diff lat, and then keep it on the same line. Now this is the one that says end the line, and it says tab it, difference, longitude, and diff long. So now I know my range. And then this one says run forever. This is the main. And if I ever have a timeout, no GPS data is found, then it will do that. Okay. So now I'm going to show you the output.
Okay, so this is the output. As you can see, you have the max on the left, latitude. Then you have the min latitude, max long, min long, difference long. And so if we start from the left, I'm not going to show you all this data as privacy issues. Um, but anyway, you can clearly get the same output with the same code I have. I showed you every single line. Um, I'm using this to track location just as anybody else, but in my own respects, which will probably be detailed at a later date. But this really just gives you a highlight on just like how customizable and usable this module is. So if you have any questions, please comment down below, like, share, and subscribe my YouTube.